Let's talk chemistry with Pastor Dan. We're looking at other types of bonds that exist. They're going to look primarily at three different types of bonds. The first of these is called a network bond. Now, what exactly is a network bond? It's considered a covalent bond in a crystalline form. So non-metal to non-metal, but it's got a crystalline, a rigid structure. Okay, second is a metallic bond. So that's going to be two metals together. Metal-metal bond with a free movement of electrons. So their electrons can move easily between them. That makes a metallic bond. The last is called a hydrogen bond. Hydrogen bond is a covalent bond involving a hydrogen to a non-metal. Now, the importance of that is it causes attraction between molecules by a charge. So called covalent structure, the hydrogen bond, the negative end and the positive end, will cause bonding between molecules due to charge structure. Now let's go through a quick explanation of the first two and a little bit longer the third before we do another additional concept. So the first is called a metallic network bond. An example of that would be diamond. Diamond is C8, so it's 8 carbons in a crystalline ring. Now they have various different forms, and based on those different forms, we get the clarity, strength, and expense of each diamond. Gentlemen, make sure you get your future bride a good diamond because it's a sign of what you need and what she means to you. So in that structure, we see those carbon structures in a covalent bond, but because of the rigidness, they are the strongest substance known on Earth. Another one is silicon dioxide. Silicon dioxide is otherwise known as glass. It is a covalent bond. When you heat it up, it forms a structure that forms bonds between molecules and allows for strength of substance. Very, very sturdy. All right, a metallic bond, metal to metal bond, just put two metals together, the same structure, and those extra electrons out there can get bounced off very easily, free movement of electrons. Now comes the interesting one, hydrogen bond. It's known as a polar bond. This is a molecule with an opposite charge across the structure. How do we do this? Well, let's look at the best example of a hydrogen bond or a polar bond. That's water. Now, we've done Lewis structures before, so there is hydrogen. Now, how many valence electrons does hydrogen have? If you look at the periodic chart, you see it only has one. Its only electron is right here at the bond. We have a proton in the nucleus with nothing shielding this entire end. As a result, that entire side is positive. Now we have unbound electron pairs over here, so that those are negative, so therefore we have an opposite charge. This is a polar molecule. So in order to be polar, we need two things. We need hydrogen. That's one thing we have. So if no hydrogen, it's automatically not going to be polar. And the second we need is at least one unbonded electron pair. So one set of electron unbonded, I think I have the hyphen there, we go. Unbound electron pair, there we go. All right, so here we have two examples. Let's do the Lewis structure of each of these. Carbon has 4, hydrogen has 1 times 4, that's 4, 4 plus 4 is 8. Over here, nitrogen has 5, hydrogen has 1, 3 times 1 is 3, plus 5 is also 8. So let's put our center over here for the methane, CH4. We have the hydrogens around it. Remember, we're going to use a line to represent 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. We're all at electrons. That's done. Over here, we have nitrogen in the center. 6 electrons are bond up. We have 2 extras. Electrons go on there. Now, this is hydrogen, so it might be polar, but there's no unbound electrons. So this one is non-polar. It's not polar because there's no unbound electrons. It's all positive. It's all one charge. Over here, we do have the hydrogens, but we have at least one pair of unbound electrons. So this one is negative and positive. This one is polar. That's a polar molecule. Hopefully those make sense. Let's go to the next concept we look at. That's called hybridization. Hybridization is a rearrangement, a mutation of orbitals for covalent bonding. So it's how we bond. One structure of orbitals move up. So we get one electron from each side to form the bond. Remember, because covalent is sharing of electron pairs. It's based on the number of bond sites. So let's do an example. Let's do water. Okay, so what do we have here? We have H2O. So we have 1, 2, those are bonds, so they count, and a double bond and a triple bond. If we have a double bond, that still only counts as one. If we have a triple bond, it also only counts as one. And then unbound electron pairs, we have 3, 4. So we have 4 bond sites. So we need 4 bonds. All right, so let's look at, remember our orbitals we had. If you remember back to electron configuration, we have S, we had 1 suborbital. We have P, we had 3 suborbitals. And we had D, we had 5 suborbitals. Now we're going to grab those and bring them up to make covalent bonds. So I need 4. So I'm going to grab 1s, 1, 2, 3 p's. I'm all out. I don't need any more. My hybridization is sp3, and that little 3 has to be raised as a superscript. sp3, that's where we had the hybridization. All right, let's try another one. Let's try argon diiodide. Argon has 8 valence electrons. Iodine has 7 times 2, 14, 14 and 2, and 14 and 8, 22 electrons. All right, argon's the center. Iodine around, bond up, that's 4, and then 6 on the outside, leaves me with 6 left over. So we have 6 extra electrons. So I have 1, 2, 3, 4, 5, 6 bond sites. So I'm going to need to use, 5 bond sites, not 6, mea culpa. 5 bond sites, 1, 2, 3, 4, 5. All right, so remember we're going to grab 1s, we're going to grab 3 p's. I'm only 4, I need 1 more. Well, I have to grab that one of those D's. So it's sp3d is a hybridization here. Alrighty. So here's 4 of you to try. Stop the recording, do the hybridization and polarity for each of those. And then when you're done, start it back up again and we'll go over the answers. All right, here we go. Ready? Here's the answers. So the first one is polar. Because we have unbound electron pair and hydrogen, it's sp3. There's no hydrogen here, so it's automatically nonpolar. We have 5 bond sites over at sp3d. There's hydrogen here, but there's no unbound electrons, so this is also nonpolar. There's 4 bond sites, so it's sp3. This one here, when you do this, yes, this is the fun one. We should have resonance in each of those. Should have brackets around them. Brackets around NH4 as well. And there's no hydrogen, so automatically nonpolar. But there's only 3 bond sites. So hybridization is sp2. All right, hopefully that wasn't too bad. Take care, be good. Bye. God bless. Merry Christmas.